Hello guys, in this video I will show you how draw on display use PNG pictures. The display we are using has 128 horizontal dots and 64 vertical dots. It displays the image that is stored in its internal video memory. This memory can be represented as an array consisting of 8,192 elements, which take the values 1 or 0. For example, the first element of the array is 0, the corresponding screen element is a black dot, 130th element of the array is 1, the corresponding screen element is a blue dot. As a result, the contents of the buffer are displayed on the screen according to the values stored in this memory array. Initially, the picture is formed in the microcontroller. Then, data is transferred via SPI to display memory and displayed on the screen. We use single-color display on SH1106 chip. Pay attention to these resistors. They define the interface type. In my case, the default is selected for wire SPI. Open Cube ID. Create new STM32 project. Enter STM32 device number. Enter project name. Set debug to serial wire. Set serial peripheral interface 1 mode to full duplex master. Leave settings to default. The Cube IDE generate pins for SPI clock and data input. Also we need create pin for chip select. Pin for data or comment select. And pin for reset. We can use any free pins for this. Now press generate code. We need to download the driver files for our display. Open GitHub. Enter STM32SH1106. Choose this. Download and unzip to your folder. We will use these files in our project. Moving files to project. Rename the file ssd1306_conf_template.h to ssd1306_conf.h. And open. Include main.h to define the names of our pins. We use STM32F4, so uncomment the corresponding line. Uncomment SPI bus and SPI configuration. Save and open main file. Include ssd1306.h. and ssd1306_tests.h. In main functions, call ssd1306_init functions. For initialize our display. And ssd1306_test draw bitmap functions. For testing our code and connect. Save and build. Compilation was successful. Connect our board to display. Chip select to PC0. Data or common to PC1. Reset to PC2. Clock to PA5. Data in to PA7. VCC to 3 volt. And GND to GND. Now upload our board. For the formation and management of the picture, we will use Touch GFX. Touch GFX generate a code that will process the image and initialize the frame buffer. Download and install Touch GFX Designer. Open st.com. Write Touch GFX. Download latest version. Unzip. Run installation file. Install. Close Touch GFX Designer. Let's generate Touch GFX code. Open IOC file. Software packs, select components. Install Touch GFX latest version. And activate Touch GFX generator. Enable graphics application. Activated CRC. In frame buffer pixel format, select black and white. Width, 128 pixels. Height, 64 pixels. Also, we need to create a timer for frame clocking. For example, timer 6. By default, we have a timer frequency of 16 MHz. We will set the timer to fire 20 times per second. Auto reload, enable. And global interrupt, enable. File, save. The generated code is in the folder Touch GFX. Open, run application template Touch GFX part file. Touch GFX designer will start. Let's make a black background. Download our PNG image from the internet. Open iconsdb.com. Choose white color. Here you can choose different pictures. It should be PNG format and small size. Click and save. Drag and drop this picture on our display. Now generate code. Right-click on the folder Touch GFX. Click Refresh. The operation of the Touch GFX engine can be represented in a simplified form. MX Touch GFX process function is called in an infinite loop. In this function, the image is processed, and the frame buffer of the microcontroller is filled. Timer interrupt occurs 20 times per second. This will call the Touch GFX signal vsync function, which triggers a flush frame buffer function call. In this function, data is transferred from the microcontroller buffer to the display buffer. Open, folder generated. File, Touch GFX configuration. Include LCD 1 BPP, it's 1 bit per pixel. Between user code begin header and user code end header tag. Open file Touch GFX help.cpp. Include this header. In function flush frame buffer, we will write code to transfer data from the controller buffer to the display buffer. And also create a function that will be called 20 times per second by an interrupt from the timer. It initiates frame refresh. File, Save. Open main file. Delete function test draw bitmap, we don't need it anymore. Start timer with interrupt mode. On triggering from the timer, call an external function, Touch GFX signal vsync. File, Save. Clean project. And, build. Build successful done. Connect and upload board. Well done.